So today we're going to learn about like LLM agents. So instead of running like a multiple choice data set on an LLM, we're going to like run like get an LLM to do like an agentic task where it has to interact with an environment. And yeah, so basically like at a high level, what LLM agents are is just like a for loop between an LLM API and some scaffolding program that's like interacting with an external environment task. So the scaffolding program is kind of like parsing the output from this environment, like figuring out the way, like the best way to feed it to the LLM, and this is kind of like what you'll be implementing. It's also like parsing the output of the LLM and feeding that back into the environment to like modify the environment state. Yeah, so we're going to handle the scaffolding program. We're also going to like somewhat handle some of the like external world, which in our case is going to be like a couple of relatively simple tasks, and we'll see how like LLMs interact autonomously with this environment when we like kind of give them like the bare bones of instructions of what to do, and then let them like go on and do their own thing. Okay, so like why should we evaluate LLM agents instead of just like seeing, oh, are LLMs power seeking? Like if we ask a multiple choice question data set, or are LLMs truthful if we ask like some truthful data set? Well, basically, so one reason we evaluate LLM agents is like dangerous capability evaluations. So it might be the case that if I just like take an LLM and put it in an environment where I like give it way more context on the situation that it's trying to, on like the goal that it's trying to achieve, then it might be able to like do much more impressive things than just sort of like asking and answering simple questions. So it might be able to actually help with tasks that we are worried about, like designing viruses and stuff. So we want to like measure how good LLMs are in these agentic scenarios. Also, like the reason, like most of the task of actually like doing an evaluation on how LLM agents are working is like making sure you're eliciting the maximum capability that the LLM has. So there's basically lots of ways that LLMs will be kind of hobbled by like presenting information in kind of like sketchy ways that aren't quite right. And if you just like, so like one like naive thing you could do is you could just like take a screenshot of your desktop, send it to an LLM, be like, LLM, like what do you do? Okay, well LLMs like first of all aren't super great at like navigating screenshots, and they aren't like super great at then like giving instructions to you for like, oh, what should I do in this situation? But if I like presented this information in like a much more complex way, so I don't know if anyone's seen the like Gemini plays Pokemon scaffolding post on Lesswrong. So I think this is like a good post for. So basically what they do is they like break up the environment into like a bunch of different grids and stuff, give the LLM information on all of these different grids, give the LLM like sort of easy ways to like path route to different locations. All of these sort of tools make like a marginal improvement on behavior, but like the sum of all of these tools lead to like Gemini beating Pokemon before Claude beat Pokemon, because the Claude, like Anthropic didn't really care that much about beating Pokemon, so they lost. Yeah, also, like the other reason to evaluate LLM agents, and we won't be really touching on this today, but I think it's useful to think about, is we, like basically all of our alignment techniques for current LLMs are just like in a chat context. Like RLHF basically operates in a chat context. We aren't really trying to align them in the context where they're like doing agentic stuff, but like almost all of our threat models are like LLMs are going to be agentic and do stuff that we like are worried about. So we should definitely like check, okay, are the alignment methods that are not trying to align them in an agentic context actually generalizing to an agentic context? And people like don't do this very much, and it turns out like they do generalize, but they generalize like worse than you would expect. Like models will give into pressure and like take bad actions like much more often than they would if you just like asked them questions and said like, would you take the bad action in this context? When they're actually placed in the context, they more likely take the bad action. Yeah, and also like basically every cutting edge eval today that is like going to be run on like O3 or O5, I guess, when it comes out or whatever. All the cutting edge evals today are like agentic evaluations. So like almost everything that Apollo is going to be working on, almost everything that AZ is going to be working on is going to be like, how do models work in agentic environments? Okay, any questions so far? Yes?
To what degree is the Pokemon example cheating? I can imagine LLM playing chess. On one side of the spectrum, you just give it like a physical picture of the chessboard and just describe an action. On the other side, I can just like API call Stockfish. And if like API call Stockfish LLM beats me, I'm not terribly impressed by the capability of the LLM. So like to what degree is this like kind of sus?
Yeah. So I think Pokemon example is kind of hard to tell because we don't know like the details of all of the scaffolding that was used there. But I think as long as like the scaffolding, you could like plausibly come up with it, I think it's like not cheating, and you're like getting the LLM to do like most of the work in the background. I think this is not cheating.
Feels like incredible domain knowledge, which in my mind is cheating.
Yeah, this I think I will come to. So I'll come to this later, but there's this distinction between like general elicitation methods and specific elicitation methods. I'll come to this later, but we're like much more worried about general elicitation methods. Those are the things we want to be focusing on a lot more. Okay.
A question, Phil.
Yeah. Oh, yeah.
If you go back to the slide.
Yep.
So there are current alignment techniques that have been designed more for the chat context. Generalized, are there like specific alignment techniques that you know of that are more specific to the agent context, or like pure RL? I think Lisa knows something about this. If you want to also.
Yeah, I don't know of any alignment contexts that work for LLMs in an agentic situation. Do you know anything, Lisa?
Starting pretty better. I think there's like pre-training with actions as well. Like train as an agent and see if it aligns in a similar way, as opposed to train as a next token predictor and then align it later. It's working on it. Yeah.
What does that mean, like action in pre-training?
Like you could put it, I don't know how they do it in detail, but at least the next token meaning an action rather than like a word in a sentence. It would be start. Like a simulated situation still in text, but specifying that it's an agent rather than just a chip.
So
Yep.
probably the objective function would be like augmented with something, not just a cross entropy, or.
I mean, you could also like potentially pre-train with RL, but we were talking about how that's maybe really hard.
Yeah, I guess you can just take RLHF and apply it in contexts that are just like not chatbot contexts and have like a more advanced reward model that's going to identify like what is the aligned action in this situation. But yeah, I haven't seen much work on this. Okay, so this is like broadly the outline for today. Like I'm kind of, based on how quickly you guys got through RLHF, which was also supposed to be like 1.5 days, maybe you guys will like finish this early. That's fine, because we have like stuff to do tomorrow relating to capstone projects. Yeah. Okay, so when you're designing like an LLM agent situation, there's basically like going to be 3 different classes that you're going to be using. One is like the agent class, the other is the task class, and then the final one is like the set of tools, which are like pretty simple class objects that you just like feed to the LLM API. And like exactly where you split up like what is happening in the task versus what is happening in the agent and how these classes are like interacting. This can vary a lot. Like the best thing that you like would want to do can vary quite a lot depending on the precise details of the task that you're trying to implement, and like I guess your like kind of what you prefer in terms of like abstracting this this information. Basically, what you'll end up needing to have is like some API interface. This is like definitely going to be in the agent class. Some like task state management. This is definitely going to be in the task class. And then kind of all the rest of this, you can kind of decide like whether you like split it up in a task class or an agent class. We've made like certain design decisions, but it's like worth thinking about, okay, in like what context will these design decisions break? Like when would I want to maybe like redesign the class and put something that is being done here somewhere else? Yeah. So first today we're going to build like a simple agent class that should just be able to like be plugged in, and you can build an agent on top of this. So this will allow us to like get the response from the LLM API and execute any tool calls that tools that we've given to the agent. Then after that, we're going to build a like slightly marginally more complex agent on top, which is just like getting an LLM to like answer simple arithmetic problems using a calculator tool. That's like the first agent we're going to build. It's pretty basic. Then after we like build this very basic agent, which is like just doing something very simple, we're going to build an agent to play the Wikipedia game. I guess I don't know how many people are familiar with the Wikipedia game. I think it usually hovers around 50%. Yeah, that seems about right. So basically, you like start on some random article, and your task is to like click the links to other articles to end up at like some other random article B. So this is like a task that is very amenable to like putting into an LLM because it basically only revolves around like navigating text data. Also, you can like vary the difficulty of this task quite a lot. Like we can have like very simple, like getting from like Barack Obama to USA, that's a very easy task. Like LLMs can do this very, very easily. And then we could have like some much more complicated task. So for example, like Albert Einstein to Aristotle, agents also solve this like very easily. You like would click this link on the Einstein page, then click this link on the quantum mechanics page, then click the Aristotle link on the Greek philosophy page. Just some like brief notes for when you're looking at like Wikipedia articles and being like, why isn't the agent getting somewhere that I thought it would get to? Basically, like all of these, like things in sidebars are disallowed, things in footnotes are disallowed, and also later on we might want to like disallow more things if the task gets too easy for our agents, and this is like quite easy to do. So we can like vary this task along a lot of different axes, and this is kind of why we've chosen it for our example. Also, like hopefully it's quite fun to like see an agent navigate Wikipedia and kind of flail at certain points. I guess I'm not going to go over this diagram too much because you'll see it today, but this basically describes how we've decided to like split up our abstractions in the implementation of like each of these classes. So we have like our wiki agent class and our wiki game class, and those are the two main classes you'll be interacting with today. But for example, it might make more sense sometimes to put like these prompts in the task class because the prompts are going to be like getting information from the task and then feeding it to the agent. In our case, the prompts like don't vary that much depending on where you are in the task because I'm just telling you like navigate to the next page or something that like takes you closer to target X. But yeah, you might want to like try thinking about like how if I like put the prompting here in the task class, how would this affect how I'm like running my agent on this task? Okay, any questions about the like previous few slides? No? Okay. So yeah, why have we chosen Wikigame? Well, basically we can quickly see how well models perform. It's like quite quick to run through. We don't have to run through a whole like Pokemon rollout or something. We can also adjust the difficulty easily, and we have like approximately the number of Wikipedia articles squared tasks. In reality, it's like less than this. We have like maybe that on 10. Is this alignment relevant? Like, no, it's just a capabilities eval, not even really a dangerous capabilities eval, but it's like useful as a trial run to get ideas for like how elicitation works in agents and to get a sense for like kind of the legwork that you have to do to like take a task, feed it to an LLM, and get the LLM to do better on that task. We can also like very quickly see if our elicitation methods, if they're general elicitation methods, are like improving the LLM's performance because I just like run the game on like slightly more harder Wikipedia articles and see, okay, the LLM can navigate these articles much more successfully if I do this elicitation method, but before I did this elicitation method, it like couldn't navigate them at all. And yeah, so I keep saying the word elicitation. And if you remember back in my like day one lecture, I kind of divided evals into like benchmarks and like red teaming and elicitation. And so far we've been working on benchmarks. This is much more of like an elicitation sort of task. We are like interacting with the model, trying to see how good it can get. We're like not trying to neutrally like determine how good is a model at this task with like no help or just like assuming some like agnostic perspective. We're like going in and interactively trying to improve the model's performance at this task, so we can see like how good does it get at this task if we like provide it assistance. Okay, any questions about this? Nope. Okay, so elicitation. Basically, by elicitation, what I mean is trying to get the best performance out of the model like that we can. So we try to do this by like improving scaffolding. For example, you can give it different tools, better prompts, different prompt frameworks. So there's like the React framework where you get the model to like first think about what it's doing and then like take an action. All of this stuff kind of like slightly improves model performance. And this like really matters when we're evaluating dangerous capabilities, right? So for example, chain of thought is a very general elicitation method that rapidly improves model performance on loads of different things. But like people didn't discover chain of thought until a year and a half after GPT-3 came out. Right? And this is like a very easy, obvious thing to do that like would massively improve our models. If there's like some other elicitation methods like this, we want to like make sure we discover them so that like someone else doesn't discover them and suddenly models are like 2x better on like every single task. This would be very concerning because then all of our like all of OpenAI and Anthropic's like risk assessments would kind of go out the window. They'd be much better. Yep. Yes.
So if hypothetically now AI safety researcher did find such an elicitation, what would be the responsible thing to do?
Tell the labs first. Tell them they might need to up their security, and then not publish immediately, I would say. Yeah, I wouldn't publish results like that without like informing relevant decision makers beforehand. Yeah. Anything else?
So if you design this like elicitation method that like doubles the performance of LLM, you think is this also like a useful cognitive technology? Like we're basically telling LLMs how to think better. So do you think that this transfers to humans? Like we've already kind of done our best to tell them how to think. We don't know anymore how to do better. So if we found out, then we also.
Yeah, I mean, I'm not a psychologist. I mean, most of the methods that you use like to improve performance for LLMs are things that I think if you were a human, you would realize these are going to improve. Like if you just think about it for a second, chain of thought is obviously going to help people think. Like if I write down all my thoughts about a topic and then try and answer the topic, I'm obviously going to do better than if I just like one shot try and answer the question. Things like the React framework and different prompting frameworks, I think these generalize less, like, oh, get the model to think first. This is just because models sometimes will just like take actions in certain contexts and they haven't given any thought about it and it's like a terrible action and then they totally flail. So I don't know how well that would generalize to humans. I think humans are like much less likely to just like take some random action because they see tools are there. I don't know, maybe you have a different take. Okay. So yeah, some like common failure modes that you're going to see when you're like running your agent is it will get stuck in loops. Like it will just like, so not even, like it can get stuck in loops in the sense of like going back to article A, going to article B links back to article A, going to article B again. But it can also just get stuck in loops about like its reasoning process. Like it doesn't really make a decision about what it should do. And it maybe like keeps calling a tool where it's already called this tool. And this tool is not going to give it any more information, but it like continues doing it because it just is something to do. This can generally be helped by like telling the LLM not to get stuck in loops, giving it like better information about what it's done in the past, so that it like doesn't exhibit looping behavior. Also, it can like these two are kind of like related problems. It can fail to see pages that it's currently on, and it can like exhibit a strong bias towards the beginning and end of any information that we give it. So if I give it like a long list of information, which you often have to do when you're like running agent tasks because there's lots of context, it will like strong bias towards the beginning of this piece of information and towards the end of this piece of information and pretty much ignore everything that's in the middle, which is like often there's a lot of useful stuff in the middle that you want to be paying attention to. This is just a problem with LLMs that exists at the moment. This is kind of like comports with their results on like needle in a haystack style tasks. You could probably improve this by like giving the like model the ability to like search stuff or like zoom in on stuff more precisely. Yeah. Okay. Yeah, and then finally, like as a bonus, once the model is like really good, kind of saturating the task difficulty, because we chose a task where you can like vary the difficulty much more easily, you can make the task harder and then try even more elicitation methods. So seeing if I can like still improve performance, even if I'm like banning the model from visiting any country pages, which like almost always very useful for this task. And like sometimes you'll give it a tool and it will perform much worse, but sometimes you'll give it a tool and it will perform much better. You can also like schedule prompts differently, track memory differently. You could like get the agent to deploy sub-agents that are like supposed to go through the text that it's seen and they don't have any other context, and this kind of will, like the LLM is kind of like gets overwhelmed by the amount of context that it sees. So if I just like give a sub-agent the amount of the context that I like currently care about, this sub-agent is going to be more able to like analyze this context. There's another method that sometimes gets used, which is human intervention, which is basically like the LLM says, I'm like really stuck, human, can you like come in and help me? My guess is that if you give this to models, they will just like ask for human intervention. Like if you give it naively to models, they'll just like always ask you to help them because they aren't very confident in their own abilities or something. They always get like worried about how they're doing. Yeah, I've seen this behavior a lot. Like the model kind of will say like, I'm stuck, I don't know what to do. I'm just like giving up. And this also is like when looping behavior starts to happen. Okay, finally, So I think like today, something that's like pretty useful to spend time on is looking at like how models fail, why models fail, and thinking about ways we can like make the model do better. This is like a lot of the task of running dangerous capability evals. Like Meta, when they run like their SWE bench or RE bench on like to generate time horizon data, they're not just like gonna like not look at any model output, like run it, see how the model does, and then we're done. They're gonna be like looking at how the model is doing, saying, okay, are there like obvious failure modes that the model is falling into? Can we fix those failure modes? Like how, and then also like what's interesting to know is how well will those fixes transfer to other like scenarios. So there's like two kinds of fixes we can do. One is like specific elicitation fixes where, oh, I'm like currently I'm like training the model, I'm running the model on like a Wikipedia task. There's a bunch of like things that will help the model do better at this Wikipedia task. But lots of those things are not going to help the model on like any other task. Like if I give it access to every Wikipedia page or some like graph of all the Wikipedia links, this is going to really help it on the Wikipedia task. This is like not going to help it on any other task. But if I schedule prompts like in like some smart way where, oh, I'm like getting the model to think without access to its tools, and then I'm getting the model to use the tools based on the output of its thinking, that like does improve performance across a wide variety of tasks. Yeah. Any questions so far? Or should I? Okay. Also, messing around with like different prompting, and also I think you should see how models are like using tools. They kind of use tools in like pretty bad ways at the moment. They kind of will like make tool calls without. Yeah, if you like give them tools, they like won't do any thinking. They will just like use the tool. Even if you tell them to do thinking, they're like more likely to just not think and just like go directly to using a tool. I think this is because of like the way OpenAI has trained their models to use tools. And then also it's like possibly useful to think about like how could I use a similar like agent framework to run like an alignment eval or a dangerous capabilities eval. Like you'd have to do a lot more work because you don't have like Wikipedia just there for you. You'd have to write like for Apollo's insider trading example, they wrote like a whole script of like, oh, this is what's happening in like our trading company. Will the model like buy and sell this share? Will the model act on this like inside knowledge that it's been given by someone that it shouldn't have this knowledge from? And they see that the model like does then act on that inside knowledge. So it's like useful to think about, okay, how can we like generalize these lessons to other alignment and dangerous capabilities evals? Okay, any questions? This is pretty much all I have. So if there's anything about agents? Yes?
Yeah, there are a lot of agent frameworks out there. I assume we're going to be doing our own stuff today. But
Yeah.
in general, are there some recommendations for which ones are worthwhile looking into?
I think Ada is worthwhile looking into for any like coding-based tasks. So this is AIDER. This is generally what people use. I think Meta probably doesn't use this, but this is definitely what Apollo used for some of their programming evals. Yeah. I don't know of any others. I mean, Inspect has like some agent stuff in it, but that basically comes down to like you'd still have to like design how the eval is going to proceed. It's not like frameworked in this kind of prepackaged way that you could use. Yeah. Yeah.
Overall, the way that you're describing elicitation definitely doesn't make me feel reassured that we would find something like chain of thought this way, that there wouldn't be something that gives like this. Is there anything you can say to reassure me?
So I guess my claim is going to be it's unlikely that something like chain of thought exists. And I think you're right, like this is probably not the way that you'd find chain of thought. I think the better way to think about elicitation is like how much can I improve a model just by like giving it information about the task that it's doing in a better way. Like, and I think you can do that. Like you can see like increased performance like up to a point where it like saturates the task, then you have to make the task harder. This like just does work. Whereas like if you just do the naive thing, the model will like get stuck much more frequently. So I think you are like you do see performance improvements. Yeah, maybe that somewhat.
I guess my question is like if you try really hard and you don't saturate the task, how can you be confident that you were smart enough, tried hard enough?
This is kind of an open problem. Like basically the way that elicitation agent-based evals work is you try really hard. Okay, we tried really hard and we like got these results. That seems like the best we can do. I guess like Meter, I think, has some like more principled, we're gonna like try hard and like spend as much money trying hard as like one would spend for like 10 equivalent humans to do this task. And if like it would take more than 10 humans, or like paying 10 humans to do the task for the same amount of time, then like it's not gonna be economical to get a model to do this, because you'll just have to like implement so much like slop in the background that it's not gonna be like as useful as just paying a human to do the work. And if models are like less dangerous than humans, then we're like not that worried about models. Yeah, it's an open problem. Like, yeah, you try your best to do elicitation and say that's probably how good the model can get. But maybe there's something we missed. This is true, yeah.
Speaking of the agents asking for help with like human intervention, do you think maybe the alignment problem is just like giving them a whole bunch of like self-doubt and anxiety so that they just stop what they're doing and just give up?
Yeah.
They can't do it.
Potentially. Although I don't know, this might generalize poorly. I don't know. Yeah.
Vanessa Kosoy does have some algorithms with similar kind of motivation, where the agent will try to avoid traps by only taking actions that it's seen a human take in the past, or that it believes a human would take with high probability, or this kind of thing.
Yeah. I will say that models like are really doubtful. Happens much less with like newer like reasoning models, especially. Like reasoning models tend to be more confident and like sometimes are therefore like confidently wrong and like mess up your entire code base or whatever. Okay, anything? Nope. Okay, that's pretty much all I have. I'll stay here if anyone has any questions, wants to speak to me directly.